Okay, so before we go ahead and actually implement the registering of our user, we need to learn about storing passwords. Now, why is this? Well, because storing passwords is a very, very sensitive thing, and we need to store them securely. We can't just store the passwords as plain text, because what if someone accesses our database and they retrieve our user's passwords, and if they're in plain text, then they could try and use the same password to access their email account, and it's very problematic. So we should never store passwords as plain text, and even in some countries it's illegal, right? So here, for example, in Spain, it's illegal to store passwords in plain text, and if some government agency has a control over or does some kind of inspection over your database, and they see that you're storing passwords in plain text, then you could get a fine. So what we need to do is to encrypt the password, okay? So what is encrypting? Okay, encrypting is essentially the process of getting some text and running it through a hash function, they're called, so a encryption function. And what this function does is basically returns a bunch of text that is not readable. And this text is designed in a way, or this function is designed in a way that the text returned is very, very hard to crack. So it's very hard to find out what the original message is, right? So imagine we type in secret message and we run it through a hash function. So the output could be this, for example. It could be just a bunch of numbers and letters and characters, that don't make any sense. And if we only have this information, it's very difficult to actually go back and see what the original message is, okay? So this is essentially the basics of how we are going to be encrypting our passwords. And so there are several hashing functions or hashing algorithms out there, and they're already built into Python, so we just need to import some libraries and that's it basically. But please do not try and write your own hash function, okay? It's very unsafe if you try to write your own hash function, because hashing or cryptography is a very, very difficult and very profound topic, and there's really a bunch of really intelligent people working on these types of problems of how to encrypt safely messages or strings or whatever, and make sure that it's very hard to crack the messages. So it's a very, very difficult topic, and so please don't write your own function. Just use the libraries that are already built. They're really easy to use, and the algorithms are safe. Okay. Having said that about algorithms being safe, cryptography is a topic which is ongoing, and the algorithms that may have been considered safe to be 20 years ago may no longer be safe, because with every year the capacity of our computers is increasing, and what this allows us to do is it makes brute forcing a hashed or a encrypted message quicker, because imagine you want to discover what this message is, right? The original message, and you know what hash function they have used, okay? What hash algorithm. So you could go and brute force the encrypted message. So you could start off with A, hash it, see if it gives this. If it doesn't, then go to B, hash it, does it give this? No. C, so on and so forth. And you could end up, finding out the original message by trying thousands and thousands of different combinations and see which one matches with this hashed string. So the more advanced the algorithm, usually the harder it is to do this attack, because a computer it could take a computer years and years and years to discover one message. So that's kind of the thing that makes crackers not want to use a brute force attack given a hashing algorithm. So the older hashing algorithms are easier to crack, or they're maybe not easier, but they are faster to crack. So that's why they are easier to crack. And the more modern ones are much more difficult, because they are much advanced. So it takes longer for a computer to break them. So that's why we should be using modern hashing algorithms. Okay, so how does our let's say encryption diagram work? Well, first on the left hand side we have someone sending us a form, and it's basically them sending their email and their passwords, trying to log in. Okay, so how do we actually check if we have a hashed password? How do we check that this password is in fact a correct password? Well, whenever they register, so whenever we create the user, they will have sent this password, for example. So we go ahead and hash it, and imagine it returns this string, okay? So once we've hashed it, we save it in our data store, and then whenever the user tries to log in, they will send us again the email and the password. So what we need to do to the password is hash the password, so we get this output, for example, and then from the data store, we retrieve the user's password for this email account, so the one that they're sending, and see if it matches. And if it matches, then we know that the password is correct, and if it doesn't, we know the password is incorrect, okay? So it's a pretty straightforward process. Now, having said that, hashing passwords is not safe enough, okay? And we will see why going to this website, okay? This website, well, this is an article which I have posted on the lecture notes. It's a really, really nice article describing about all the different things you need to know about storing passwords. And it's pretty in-depth article, so I recommend you go ahead and read it. But if we go to the home page, we can see that they have this free password hash cracker. Now, what is this? Well, essentially, what they have done here is they have pre-hashed a bunch of the most common words or strings that people use as their passwords, right? So imagine they have a database of words matching their hashed version. So what you can do is simply type in the hash here, and we'll go to the database, find the hash, and return the original value. So you don't even need to calculate this because it's already pre-calculated and stored in a database. So let's run a quick experiment. So I'm going to open up my terminal, and I'm going to enter the command line of Python, and I'm going to import the library which hashes strings. So it's called hashlib for hash library. And now I'm going to simply hash or encrypt a message, okay? I'm going to say hashlib.md5. MD5 is the algorithm I'm going to use. And now I need to pass in a string. So I'm going to say password, okay? Password is going to be my string I'm going to be hashing. And now I need to run the hex digest method so that it actually prints out the string. Okay, so this is my hash for password, okay? So let's go back to this website, paste it here, and see if this is able to crack it. Okay, let's see how long it takes. Wow, that was quick. Let me see the results, it's password. So they have found our password given a hash, and they even know what algorithm it is. It is MD5. So here we used MD5, and in fact it is MD5. So this just gives you a sense of why hashing passwords is no longer enough. MD5 is one of the algorithms that's no longer considered as safe, so we should never use MD5 for hashing passwords. It's used for other things, but not for hashing passwords. So I hope this proves the point. But the next question is, what can we do to make sure that, you know, our passwords aren't broken or cracked? Well, there's a concept that we need to apply, which is the concept of salt. And salt is nothing more than a random string that we append to the message, okay? So imagine we want to hash secret message. So instead of just hashing secret message, we hash a random string concatenated to the secret message. And this gives us a different hash output, okay? Now, in order to be able to retrieve the password and check it in our database, we also need to store the salt, so the random string, separately, so that whenever we check the password, if it's valid, we need to again hash the password that they're sending and the random string. And if both give the hashed output that we store in our data store, then it's correct, okay? So here we can even see they ask us to enter up to 10 non-salted hashes, because salting hashes gives much more randomness to the initial input. So instead of password, it could be, you know, let's try it, right? Let's go here and say MD5 of just a bunch of random string, okay? So this is the new hash. And now if you go and try to crack this hash, it may take a while. See, it's not found, okay? It's not found in the database because we've added a salt, essentially. So this hash is no longer found. So we can see that securing a password with a salt is very, very effective. So this is what we're going to be doing in the next lecture.